I forget. What do you guys wanna need help on?
I need help on a conversion factor, but we could work on anything because I do need to make sure I know everything.
Okay, so what specifically about conversion factors?
It's converting the metric units.
Okay, so find a problem that you've tried and you don't know and you got it wrong. Find one and then we'll work on that one specifically, okay? So while you're looking for that, Cameron and Kennedy, you guys have anything?
I'm kind of the same as her, but like the ones that have the
cube.
Yeah, those ones.
Okay. How about you, Kennedy?
Okay, so I did some practice problems already, like the ones in the back of the book, and then I found some online. So then I started to look at the old exams again, and I tried to do, this question is asked, their home is 4.34 times 10 to the first power giga feet away. And then if you arrive at 5.
Do you have a, because it seems like it's a lot of numbers. Can you take a picture of it or put it, scan it or something and show it so you can share it and we can see it?
Wait, I think I can just share. Wait.
Yeah. So I think this will be good because that question actually takes care of Cameron and Kayla's question. Not exactly your cubed, but well, yeah, it's a, no, not exactly your cube, but still it's a conversion problem. So that'll help.
Okay, wait. Can you see it?
Yep.
Okay. Do you need me to zoom in? Because
no, I like to so what number is it? Oh yeah, it's number 2. Okay. So if you notice, I don't know if you noticed, but this is my last 2019 exam, right? So this is what you guys should be looking at because this is how it's going to be, right? So this is number 2. It's worth 25 points. And it says you decide to visit your friend for the weekend. Their home is 4.34 times 10 to the first gigafeet away. What? But okay. If you leave at 5 on Friday and travel 33.5 meters per second, what time will you arrive? Or when will you arrive? So did you try it?
Yes. Okay. So this is what I did. So the first 10 power, I had to move so I made it 43.4 and then I had put 10 to the 9th power of gigafeet, and then
why'd you put 10 to the 9th? Why did you change that?
Because gigafeet is 9, right? It's 10 to the 9th.
But it's 43.4 gigafeet. So, can I write? I can't. Hold on. Let me edit it on the screen.
Can you?
I think I can. So.
You want me to scroll down?
Nope.
Okay.
43.4. You changed it because you took off the scientific notation, right? Mm-hmm. But it's just giga.
Oh,
wait, giga's wait. Oh, hold on. Jesus, I can't. Oh my goodness, how do you erase? There we go. Okay, so it's just giga feet, like that.
Oh, and then I had to convert it to the.
Yeah.
Okay. Wait a minute.
Okay. Yeah, you added another billion.
Yeah.
When you added the times 10 to the 9th. So anyway, I guess let's finish the problem, right? So you did, that is the same thing, 43.4 gigafeet. It says you travel at 33.5 meters per second. So that's 33.5 meters per second. Okay. It's asking you for a time, right? So it's asking you what time will you arrive? So obviously it's going to have to be somewhere along the way. The answer is going to come from this, from the time. Okay. We're not there yet, but that's what we're headed towards. So it's good to understand, where you start, where you're headed. So you have gigafeet and then you've got meters. So those are both units of length. So you can talk, they can talk to each other, right? So you just have to make them talk to each other. So what I would do, well, let me not tell you what I would do. What would you do?
I went from gigafeet to normal feet, and then feet to yards, and then I went from, well, I tried to go from yards to meters.
Do you know that conversion?
No.
Neither do I. So why would you go there?
So then I was thinking, so should I have went, instead of doing it, should I have just went from like feet to like centimeters? Because I know that centimeters in, like I can get 12, well, I can go to inches, can I?
Yes, that's what you should have done. Yeah.
Okay.
Okay, so just so we can map it out for people, first of all, there's only 4 of you here. So do you guys understand what she's talking about? Like, do you get what she's trying to do? So the thing is asking how much time, right? What time are you going to get there? And the one of those units is time. So we're not going to deal with that right now, because first we've got to make the other units talk. That's all it is about making units talk, right? So you've got meters and gigafeet. They're both units of length, like she was saying. It's just now you got to convert giga to somehow a gigafeet to a meter. And she went around the way, I don't know what she did, yards, meters, blah, blah, blah. But the easiest way would probably be going, can anybody tell me? Like step by step besides Kennedy? Anybody else? It's only 4 of us. Don't worry about being wrong.
Can't you go straight to meters?
Do you know the conversion between gigafeet and meters?
Oh no, not like that.
Because if you do, you should be teaching this class. Because I don't know that.
No, I mean, if you went from there to feet.
Okay, so gigafeet to feet, speak, right?
Right.
Specifically.
Yeah.
So gigafeet to feet. Okay, we can do that, right? Because that's just the power of 10. Okay, now we're in feet. Now from feet, where do we go?
See, I was gonna check our sheet because I thought maybe we had a conversion for meters that went to feet. But if we don't, then we can go to inches, and we know what inches and centimeters are because we know that one.
Yep. And then from centimeters go to what?
Meters. And then that's where you can transfer to the.
That's when you can use this little second guy. Exactly. So let me write that so people can actually visualize what you're talking about. But that's exactly what you do. So you would go from gigafeet to feet. And I'm going to call on you, Kayla, in a second. So since you have problems with conversions, so gigafeet to feet, but let me just write the path. I would go from feet to inches, and then from inches to centimeters, and then from centimeters to meters. I'm going to stop right there. Let's go back and fill in all the stuff. So, Kayla.
Yes, ma'am.
What is a giga? Do you know the power of 10 for a giga?
I honestly want to say 10 to the 10th power, but I feel like I'm wrong.
Usually they don't go in 10 to the 10th power. That's not a common one. If you look at them carefully, they usually go in threes. So 3, 6, 9, 12. So 10 is an uncommon one. Right? So the ones that I have on my list that I told you need to know, they go in threes, 3, 6, 9, 12, and like even on the negative side, -3, -6, -9. So they go in threes. So not 10. Try another one. It's close.
I know it's big, so it's either 9 or 12.
Can somebody help her?
It's 9.
It's 9.
9.
Yeah, so a gigabyte, like in your computer, that's 10 to the 9th bytes, right? So it's 10 to the 9th. Okay, that is correct. A giga is 10 to the 9th. Where do I put that power, 10 to the 9th? Do I put it at the top with the feet, or do I put it at the bottom? Because remember, we're trying to make a relationship between those two units.
Do you want me to answer?
Sure. Anybody.
You can put it at the top.
Okay. Put it at the top. Kayla. She said put it at the top. Do you understand why she said put it at the top?
Because you have to use, I know how to, it's.
Relax.
I know why, is that I can't really say it right. Because
you have to be able to say it. You get that though, right? Because if you say
yes,
it,
ma'am,
then you understand it. So it's really simple. If the reason she puts it on top is because 10 to the 9th means something. That means a billion.
right?
That's a big number, right?
So you need like a billion feet to equal 1 giga.
Exactly. That's exactly right. That's why she puts it on top. Do you understand why if she put it at the bottom, that wouldn't make sense?
Right.
Right, because you're saying that 1 foot, one little tiny baby feet is the same thing as a billion gigafeet, which is not correct. Somebody's phone. There you go. All right, so that's right. 10 to the 9th equals 1. Perfect. This is easy, the next one, because it's just 12 inches is 1 foot. That you should know. But I think that's also on your sheet. Anyway, the centimeter in inches, guys. Which one? What's that one? That one you have to remember, right? That one you have to memorize. So what's that one?
1 inch is equal to 2.54 centimeters.
Good job. And then I'm back to you, Kayla. Because you wanted help with the conversion, the metric unit. So you have a meter and a centi. Do you know what a centi is?
A centi, yes, I do know what a centi is.
Okay, what
the
power?
Centi is 10 to the 3rd power.
Nope. Doesn't centi?
Oh wait, 10 to the 2nd. But
it's smaller than 1. So 10 to the -2nd.
Oh, I missed the negative.
Yeah, that's important. That's really important. Because you're saying 10 to the 2nd would be 100. And then 10 to the -2nd is 0.01. Yeah, that makes a big difference. So
I forgot the negative.
Yeah, so it's 10 to the -2. Okay, where would I put 10 to the -2?
By the meter.
Good job, because the meter is bigger. So 10 to the -2 meters is the same thing as 1 centimeter. Okay, so good. We're here. We're at meters. We still haven't answered the question. The question asks how much time. So the only thing you haven't used in this problem is right here, this thing, meters per second. So I'm not going to do it. You guys tell me what to do. What would you do now?
Just put that as the next conversion.
Okay, but what do I put at the bottom?
At the bottom, you put meters because we're going to end up with seconds.
Well, somebody erased it. Don't erase it. Somebody erased my thing. Anyway, so the meter, so the 33.5 goes at the bottom, right? 33.5 meters over second, right? Yes. So if you look, we're pretty much done, but everything cancels. Let's just make sure. Inches, centimeters, meters. We're left with seconds. Fabulous. So now we just have to figure out, how does this make sense for the answer, right? Like, how does this fall into the oh, Jesus, hold on. Erase, mouse. This is a lot harder when I'm not on my OneNote. There we go, draw. Okay, so now we've just got to figure out, okay, why did it erase? It erased everything. Oh, Jesus Christ. This is really annoying me. 33.5 meters per second. There you go. Okay, so can anyone tell me what to do from here? Because at the end of this calculation, whoa, you guys, what's going on? What is that? What just happened? Anyway, at the end of this calculation, you're going to end up with seconds, right? But it's not asking you how many seconds. It's asking you at what time would that person arrive. So what would be the smart thing to go to?
Would you just continue going to minutes? And
yeah,
then you can do that later?
Well, I would do it now. Why do it later? Like do it now, right? And figure out how many
Uh-huh.
minutes it takes to get there, right? And that's pretty much the answer. So I would go seconds to minutes. In 1 minute, there's 60 seconds. And then someone give me that answer. I don't know what that answer is, but someone give me that answer. And at least 3 of you have to agree on this answer. So get your calculator and make sure you know how to use your calculator. I will say before, since this is the first time we're doing it as a group, that 10 to the 9th thing, when you see when you have those powers of 10 in the problem, no one's paying attention. Hello, look at me.
Oh, I'm sorry.
Thanks. So whenever you put that into your calculator, don't put 10 to the 9th. You got to put 1 times 10 to the 9th. You understand that, right? Because then your calculator thinks it's 10 times 10 to the 9th, and that'll be off. Okay. I'm going to do it just in case to make sure everyone. What's that first number? 43 point what? What did it 43.4. Yes, 43.4 times 1e to the 9th times 12 times 2.54 times 1e to the -2 times, nope, divided by, open parentheses, 33.5 times 60, close parentheses, equals. Okay, I have a number. Did you guys get a number?
Yes.
What number did you get? I would like it in scientific notation, if you could, please.
Okay.
Your calculator does that for you, by the way. So if you don't know how to do that, you should figure that out now before you get to the exam. Because there's a button on your calculator that automatically puts it to scientific notation. So learn how to do that. I'm on my calculator. I'm on my phone, so my phone does not have that. So I have to do it. 1, 2, 3, 4, 5, 6. Okay. Yeah, give me.
I got 6.58 times 10 to the 6.
6.58 times 10 to the 6 squids.
Minutes.
Okay, minutes. That's a whole lot of freaking minutes. Okay, so what do we do now? Did we do this right? Because that seems like a lot of minutes. Maybe we should have converted it to days.
Mm-hmm.
Right? Because when are you going to get there? That's a lot of freaking minutes. That's like 1,000,000 minutes. Let me make sure we did this right. Gigafeet, E10 to the 9th, 12 to meters per second, 60. Yeah, that's the correct setup. So I would probably, what I would do is I would go ahead and see how many days that is. Minutes into hours, hours into days. So that's 60 minutes in 1 hour, 24 hours in 1 day. So what's that? 6.5 divided by open parentheses 60 times 24 close parentheses. That makes it a lot. Holy crap, that's 4,570 days. There's something wrong here. There's no way that she would have done this. Well, maybe, well, you know what? I didn't make this problem. Kamaria did. So maybe she did make it specifically like that. So what time, if you leave at 5 p.m. on Friday and travel 33.5 meters per second, when will you arrive? You will arrive 4,570 days after you leave. That's what I would say.
I have a question, Dr.
Yeah,
Carney.
go ahead.
So for questions like these, how did we determine the amount of sig figs to report?
Great question. Can someone answer that for her? What is the rule? There's a rule.
Yeah, I remember the ones about like multiplication and division, but I guess since we do it in these long things, it's like
No, there's a
confusing.
rule about when you have a problem. Like
Oh, okay.
So does anybody know what the answer to that is? What numbers do I take into account when I'm calculating sig figs?
You take the shortest one, well, not the shortest ones, but the one with the least amount of sig figs.
No, so
like,
yes, the answer is correct. What you're saying is correct, but that's when all of the numbers matter. What she's trying to ask is which number do I actually, I mean, do all of them matter, or do I only take into account certain numbers in a problem? So the answer to that is you only take the values that are actually measured. So in this problem, they measured 4.34 times gigafeet. They measured the distance and they measured her rate in the meters per second. So both of those numbers are taken into account. What is not taking into account is, for example, I don't know, as for example, if they say, I don't know how to give an example, but things that you don't measure in the actual problem, don't take those into account, right? But those two things, somebody measured that. So you take those into account. Both of them have 3. So that means that the final has to have 3 because all you're doing is multiplying and dividing.
Okay, so if the second number had 5 sig figs, how would I determine it then?
Well, then you take the rules. Because since you're multiplying and dividing, you take the least number of sig figs, so your answer would still be 3.
Okay.
Okay. So, Kennedy, do you have the answers to this question? Like the key?
Do I have the answer?
Yeah, did I provide the key for you?
Wait.
If it's on there.
No.
It's bothering me that it's so big. But anyway, that to me is how you would set that up. And then you can go from there. It is pretty big. I mean, these numbers are pretty big.
Let me go check. Because I don't think it was on there.
You were lagging. What did you say? I think she's stuck. Okay, so I'm going to clear everything. Is that okay with everyone? All right.
Yes, ma'am.
All right, so does anybody, oh, I don't know. I guess I can't, doesn't let me clear. Okay. Anybody have any other questions? She's stuck. I think that's the problem. Yeah, I think her thing is stuck, so it doesn't let me do anything with her thing. Kennedy, are you still there? Oh, there she goes. Okay. What's up? Cameron, go ahead. Did you have a question? Or Tamia, did you have a question?
I did.
Okay.
Would you be willing to work out the problem that was on? Yeah.
I think you're unstuck, but you're really slow.
Yeah.
The internet in my dorm went out, so you're...
It's okay. It's okay. Just, you're still there. Whenever you kind of, I can still see you, but you're lagging. Anyway, sorry, Cameron, go ahead.
Would you be willing to work out the problem that was on our quiz?
The quiz 1?
Yes.
Yeah, sure.
I tried that one so many times.
So I bet you it's the one that Tamia had a problem with.
If it was the one that was referenced in class today, I think so.
Oh, referenced in class today?
I think she asked in class today.
Oh, yeah, the cubic whatever to gallons.
Yeah,
Tamia, do you want to take over?
I would, but I couldn't find that sheet.
You couldn't find the sheet? Really? That's the excuse?
No, really, the constant sheet and conversion sheet. So then I started Googling it to see if I could find it because I checked Blackboard.
No, I made it. You can't Google it. I made it.
But where did you put it? Because I was checking Blackboard and I checked chapter 1 and then I checked course materials.
No. I said under course overview and materials, there's a folder that's called equation sheet and constant sheet. So let me show you. How about that? Because that really should not be the reason why you didn't try it, right? No, it should not. So that's not it. So here's your thing. Here's the folder, right? Course overview and materials. If you go and you scroll slowly down, you see right here, equation and constant list for exams, right there. That's where it is. Okay. So here they are. I forget what that question asked. So can someone?
I have it written down.
A simple conversion, right? It was
25,800 gallons, 2 yards cubed.
Okay, hold on. Let me change the size of my pen. Let's go to this size. Yeah, that's good. Okay, so I'm gonna put you guys down because there's a lot of writing here. So 25,800, right?
Yes.
Gallons. Does anybody, and sorry, to what? To cubic yards?
Yes.
Okay. So does anybody have that sheet with them?
What sheet? Oh, do you mean the conversion things?
Yes, the equation and constant sheet. Because you need that. I don't know any of this. So
right. I have all of my stuff written down. I just don't know where I went wrong. Like I have the conversion from gallons to liters and stuff like that. If that's what you're talking about, it's written down.
Yeah. So gallons to liters. Can't wait. So gallons to liters. Yep, that would be the one that you would use. So you would start out with 25,800 gallons. Can you tell me the gallons to liters?
Yeah, 1 gallon is equal to 3.785 liters.
Okay. From here, you got to go to milliliters. Sorry, my bad. Liters to milliliters.
Right.
Okay. And then milliliters. Hold on. Milliliter. Oops. Should I not do this? How about what? Tell me what you guys did. Because if I just tell you what to do, then it doesn't matter, right? What did you guys do?
Do you guys care if I answer? I've been talking a lot.
No, go ahead.
Okay, so I started exactly how you're starting. And then I went to milliliters to centimeters cubed.
Okay, so you went milliliters to centimeters cubed. Okay.
And then from centimeters cubed, this is what I wasn't sure about, is because now that it's in volume, you have to get to length.
But you are in length. You're in centimeters.
Okay, so then from there, I put centimeters cubed and then like centimeter above it.
Okay, wait, centimeters cubed and centimeter above it?
Yeah.
No.
Ms. Tor?
Yes.
I have a reach.
Yeah, I know. You gotta go. Yeah, go ahead.
Yeah. Okay. Thank you.
See you later. So you have here you have centimeters cubed here.
Right.
You gotta now in a sense you have to pretend that you don't have the cube.
Okay. So then do I just go straight to inches?
Centimeters to yards. Yes. So you would go from centimeters to inches. Oh my God. What the? There you go. Centimeters to inches.
And then inches to feet and feet to yards. That's what I did.
That's it.
Really?
Yes, that's it.
Okay.
Except this, now all of this is cubed. Cubed, cubed, cubed.
Oh, see, I thought since you showed us that example when we did the notes over it, I thought that it was a thing where you only multiplied one of your conversion factors.
No, of course not. Because then if you only did one of them, you would have inches cubed, and inches cubed doesn't cancel with inches.
Right. That's where I was getting stuck, is because I wasn't able to cancel my units.
Yeah. No. So you can cube or square however many times you need to.
Okay.
Okay. So then this would be obviously everybody filling in 1 foot, 12 inches, but everything in there is cubed. Cubed, like
Right.
12 times 12 times 12. Anyway, how many? There's 3 feet, right, in a yard? Yeah.
Yes.
This is 1, 1. This is 10 to the negative 3 is 1. There you go. That's how you do that problem.
Okay.
And that would give you your answer. How many sig figs does that answer should have? Anybody? How many sig figs should that answer have? You should only, this should not be like, I mean, this should be easy.
Is it just the least number of sig figs?
Okay, but you have a lot of numbers here. So which one is the only one? Kennedy, you wrote it in the chat, but I want, if you that's the number you say, explain to me why. You can't say the least number because look at this, look at these numbers. This is 1, this is 1, this is 1. Why don't we take those into account? This is 1.
I think you don't take them into account because you didn't start with those.
You didn't measure those. You didn't measure
right.
those, right? Right. So the reason you say 3 is because this number here is the only thing that's measured. They measured that 25,800 whatever gallons. So that only has 3 sig figs. So that's why the answer is 3 sig figs. Because all of this are just conversions. You didn't measure any of that. Do you understand? Yeah?
Yes.
Okay.
And then isn't the, where it says 10 to the negative 3, wouldn't that be 10 to the positive 3 for milliliters?
Yeah. Oops. My bad. Good job. Correct. It is 10 to the positive 3 millis to get to 1 liter. What else? What else do you guys want to do? Hi, Davion. You just came on. Do you need help with something?
I just came to watch just to get any extra info.
Okay. So it's your floor, Cameron, Tamia, Kennedy. If you can talk, Kennedy, I don't know. You're lagging.
Can you hear me now?
Yes, now I can hear you.
Okay. Oh, it says my internet sensitive. I'm gonna go back out again, but while I have one question. I wrote it down. Let me find it. Well, I'm looking for it. Somebody else can go or.
Cameron, Tamia, what you got?
I didn't have a question, but I remember at the end of class we were kind of rushing and you were talking to us about the things that we needed to study for our first exam and a lot of things about the periodic table that you were talking about. So like we need to know our elements. We need to know, So you said we need to know our elements, which I understand that, but there were some other things that you listed. So I wanted to ask you what those things were.
Who knows? I talk a lot.
I think you said something about polyatomic ions.
Oh yeah. So we haven't even gotten to that. So you need to know all the naming.
Okay.
All the naming. So you need to know polyatomic, and the reason I stressed on that one is because those are the hardest ones, right, Kennedy? Polyatomic ions are the hardest ones naming.
Yeah, but there's a video. I could send it to you and you can just like listen to it. It's really annoying, but it helps you like remember.
Makes sense.
Like torture. It's like a torture. It's on a loop.
Yeah.
But anyway, so you need to know all the naming. So that's the naming for polyatomic ions, for bases, acids, hydrates, ionic naming, so ionic compounds and molecular compounds. So just all the naming. And not only do you need to know that, but you need to know sort of every which way, right? Like that's what I was screaming at the end of class. I was saying that, for example, I'm going to give you stuff in names, like the actual name of it, right? So I'll say, okay, so I don't know, let me see. disulfur hexachloride, right? And I'm going to write that in a name, disulfur hexachloride. So you have to know what the hell is that and put it into a formula. So that would be S2, hexa means 6, chloride is chlorine, so it would be Cl6. You got to do that, right? So that's a molecular compound, and then you got to do the same thing for the ionics. If I gave you something like, I don't know, rubidium fluoride would be RBF. So you have to be able to put that into, put them into molecular compounds, take them out of molecular compounds into their names. So all of that. And those are the easy ones. The ionic is easy. The moleculars are easy. The hard ones are the polyatomic ions, because look at the word. Poly means more than one. So more than one atom together in a unit. So it's really hard for students at the beginning, because I'll say you have to know, and I'll just give you some of them, right, that I can remember. I think there's like a list of like, I don't know, 20 of them, but there's nitrate, phosphate, bromate. Help me out, Kennedy. What else? Nitrate, phosphate, what?
Permanganate.
Permanganate. Oh my gosh, sulfate. There we go. I'm forgetting them. Sulfate, carbonate. You see what I'm saying? The list keeps going and going and going and going. And all of these, not only do you need to know, like, oh, okay, nitrate, you need to know that it's NO3 minus 1. That whole thing has a minus 1. That's difficult for students at the beginning, right? This is PO4 3 minus. Nothing like, oops, wait, sorry, 3 minus. Nothing like the first one. So there's no trend, which is really hard for students. What's bromate? Do you know, Kennedy?
Isn't it BRO?
Come on.
Is it 3 after
yes.
that? Okay.
3, BRO3, what minus what?
Minus.
Minus what?
I don't know the minus, but I know.
Well, then you would get it wrong. So there you go. It's minus 1, right? So at least you got 70% of it right. But permanganate is MnO4 minus 1. Sulfate is SO4 2 minus. Carbonate is CO3 2 minus. The good thing is that they all have oxygen. And that's why they're actually called, oh my gosh, what's the word for them? Oxyanions, oxygen anions. So they all have oxygen, but it's really difficult. The one thing that I could tell you is that these ions sort of, if you look at the periodic table, actually we have one. So look at this. So you see on the left-hand side, let me erase that, but nitrate, well, not nitrate, nitrate actually doesn't work. But for example, phosphate, you see phosphate here? And look at bromine. Bromine's right here, right? And sulfur. Sulfur works too. Sulfur's right here. So phosphate is in the 5th column, right? So phosphate, to become an ion, needs 3. Look how many negative charges that polyatomic ion has, because it's in the 5th column. Bromine only needs 1 to become happy, so it has a minus 1. Sulfur only needs 2 to get to argon, so it has a 2 minus. But then you're like, oh, okay, great, that works always. No, because then look at nitrate. Nitrate is in the 5th column, but then it's only a minus 1. A lot of them work, but a lot of them don't work. So you just have to remember them. You have to remember them. And then these are the anion form, but then each one of these anions can become an acid. So think about that. It's not the same name. It's a completely different name now. So this is one of my old tutors, and I'm going to say this in class again, but one of my old tutors used to have like a little thing that she would say, like a little thing to remember. So all the what was it? I ate something icky, right? So I ate something icky. All of these guys, if you notice, they end in eight. So I ate something icky. That tells you when they become an acid, what ending it has. So nitrate, when it becomes an acid, becomes nitric. Ate something icky. So nitric acid. That's a Nitric. Oh, whatever. Not ICK. Jesus, let me rewrite that. Nitric, right? Phosphate becomes phosphoric. Bromate becomes bromic. Permanganate becomes permanganic, right? So at least there's some things that you can use to help you remember, but it's just a lot of words. Carbonate becomes carbonic. Sulfuric. And the acid form would be when you add a proton. So it's the same thing, except you add a proton and you take away the charge, right? So phosphate would become phosphoric. I know I've gone into the deep end here, but you asked. So this would be H3PO4 and so on and so forth. So anyway, that's what's coming. That's what's coming. And you got to know them because everything is in words. So you got to remember them. All right. Anything else? Do you guys want to keep doing that or you want to do something else?
Okay, wait, I have a question, but we don't have to do it.
Okay.
I just have a question. Okay, right. So I was doing one in the back of the book and it said where did it go? M/S, that's meters per second, right?
Ooh, what's meters per second?
It says, okay, so it says 1,255 M/S.
1,255 M/S.
That's meters per second, right?
I would assume so. I would write seconds like this, but yeah, okay.
And then it says convert that speed to miles per
Oh yeah,
hour.
then it has to be second because it's telling you it's a speed. But anyway, go ahead. Convert that to what?
Meters or is that miles? Because miles is M and meters.
No. Meters is M, miles is MI.
Okay. That was it.
Okay. We can do it if you want, or unless somebody else has something else they want. Or actually, now it's only Cameron and Kennedy. I guess it's boring. I guess these study sessions are boring. Okay. So what else do you guys want to work on? We can do that problem if Cameron doesn't want to.
I wouldn't mind doing another conversion.
Okay, so
did you do it already?
I did it, but you can do it. It's in the book. Do you have the textbook?
Yeah, I have it with me. I just I don't know where you're looking.
No, I'm about to tell you.
Oh, okay.
Go to page 31, right?
Yeah.
Number 1.41. And then you see it says about helium.
Yeah, I see what you're saying.
That's the one. So
oh, okay. We can do it.
So it's meters per second to what?
Miles per hour. Yeah.
This is easy. Come on, guys. Let's do it. But Jesus, really, Kennedy? Okay.
I didn't know if it was meters or if it was miles. And I'm like, I know if you put miles per hour, and then I was like, it's just MPH. But I thought miles, it was.
Yeah. Why don't you just shut up before you're ahead? Just shut up. Okay. So how about Cameron? Do it with me on the screen. Tell me what to do.
Oh boy.
Yeah. Come on.
Okay. So don't we start with like the top unit?
You can start with whatever the hell you want. You tell me what to do.
Well, let's start with meters. So we got to get meters to miles.
Okay. So
okay.
Tell me what to do.
So first meters goes on bottom. And then let me think. Do we have to go all the way down to Or is there a conversion that I'm missing?
I'm going to let you think through that.
Okay, I can check what our page says. I haven't pulled it up.
But you know that even without looking at the sheet, you should be able to do it because you just
Right.
do it up top.
Yeah, that's why I asked, do we need to go all the way down?
Yeah, I would just not waste time looking at the sheet and just do it the way that you know how to do it.
Okay, so.
Because I think, you know what, to tell you the truth, there is something that goes from meters to something, but who cares? Just do it. Do it the way you know how to do it.
All right, so meters to centimeters then, and then we'll do centimeters to inches.
Okay.
And then we'll do inches to feet.
Okay.
And feet to miles.
Okay. So you're done with the top. Good job.
Done with the top, yes.
So now what do I do as far as the bottom?
So now I need to move on from seconds to miles. I mean, hour, my bad. Seconds to hours. So I put S on the bottom. Well, no. S on the top.
Mm-hmm.
So I have hours on the bottom. Oh, well.
You can do that if you know the conversion.
I'm gonna write the whole thing out so I can use this as notes.
Okay.
Okay. Seconds to minutes, and then minutes to hours.
Okay. So just for FYI, there's 3,600. Think about it. There's 60 minutes in an hour, and there's 60 seconds in a minute. So 60 times 60 is 3,600.
Right.
3,600 seconds in 1 minute. So you could do that too. But anyway, so seconds comes with seconds, and then minutes. So there you go. That's it.
Yep, that's it.
So easy.
Are we gonna solve it out or just?
Nah, that's stupid. Don't do that.
Okay.
How many sig figs would it have though?
This one would be 4.
This one would be 4. Exactly.
Yes.
All right. So this would be, just to make sure, 10 to the negative 2 is 1. This is 1. This is 2.54. This is 12. This is 1. This is 1 mile. I think is 5,280 feet. That should be on your list.
Yeah, that's what I thought.
Yeah, 60 and 1, and then 60 and 1. There you go. Equals answer. Okay.
Have you done any of the other ones on that page?
I think she's talking to you, Kennedy. Yeah.
I did, but I jumped in because I like to do them online because, you know, online you could just find different levels. Like these are different levels, but if you want to go to the hardest ones, they're in the back. Well, not back, in the back.
Yeah. The further down you go, the further in the numbers you go, the harder they get. So I would suggest definitely looking at the later ones.
Okay. What about the one at the very bottom, the very last one on that page?
What number is it?
1.52. I don't know if you've done that one already. The one talking about ammonia gas.
You want to calculate density?
Yes, calculate its density in grams.
Okay. No, I didn't do this one, but we can do it though.
Okay.
Okay. So you know the density formula?
No.
Density.
Okay, so actually this is a great that you guys brought this up. So Cameron, just because we did not go over density in class does not mean that you will not see a density question in the exam. All right, so how do you know what can be covered is you look at the study goals in the, on you know, in every chapter, there's a thing that says study goals. That's how you know what is going to be on the exam or what could be on the exam.
Okay.
Yeah, so even though I didn't have time to cover it in chapter 1, density is very important.
Okay.
What is the, what's the formula, Kennedy, for density?
Density is mass.
Mass over volume. So that could be any mass unit and any volume unit. But usually it's grams per mil or sometimes grams per centimeter cubed. So any one of those could work. All right. So what does the problem say?
Says ammonia gas is used as a refrigerant in large-scale cooling systems. The density of ammonia gas under certain conditions is 0.625 grams per liter. Calculate its density in grams per centimeters cubed.
Oh, that's easy. Okay, so all they want you to do is a conversion. So tell me those numbers again. 6.25?
Oh, 0.625. And then grams per liter. Calculate its density in grams per centimeters cubed.
Come on. This is like baby work. Okay, go ahead, do it. You don't even have to worry about the top. All you got to do is change the bottom.
Oh, just liters to, oh, I didn't realize that. Okay. Oh, do you guys want me to do it? Or?
Yeah.
Oh, okay.
Tell me what to write.
Well, it's because she said she didn't do it either.
Okay,
so.
Kennedy, you tell me what's right. Hey, do you see this on the screen when I'm like, do you see that little moving thing or no?
We don't, but I can see when you write.
Oh, okay. Because I'm like actually just moving the cursor and it shows up on my screen, but it doesn't show, you don't see anything right now, any white little, okay. So anyway, go ahead. So go ahead, Kennedy, tell me what to do.
Okay, so you put liters at the top and then put milliliters at the bottom.
Mm-hmm.
And then you put milliliters at the top and then you put cubic centimeters on the bottom.
You're done. So this is 1, this would be, oh God, what is this? 10 to the negative 3? Yeah, 1. That's it. Answer. That's it. You're done. Good job. Let's do like a hard one. Like, get me like, whoa, that's hard, guys. Let's do that one. Let's do one of those because we only have like 7 minutes left. So let's do a really hard one. Actually, I'm gonna look in the book. Let me see. You guys look, but I'll look too.
Oh, okay, wait. You said you looked for one.
So how about okay. So hold on, let me get my keyboard back connected. And yes. How about, you can look, which one did you have that you said, Kennedy?
Oh, there's one.
Let me stop sharing for a second.
It says, in water conversion, the chemist spreads a thin, well, I could just type. Do you have the textbook? Well, she has a textbook. It's 1.115. And it's on page 35.
Oh yeah, but those are modeling and estimating. Let's stay away from those because that I won't ask you.
Okay.
Mine is really close to that one, but it's not in the interpretation section.
Is it 102 or is it 104?
No, it's actually I was looking at 191. Read it for a second. Just take a second and both of you. It's 1.91 on page 34. And tell me if that number scares you.
Calculate the number of atoms. Okay.
Let's do that one.
Yeah, so this one is actually quite easy. All right, it is. It's just that it's incorporating like a density and then conversion, so people get really scared. And also a cylinder, so you kind of have to know certain things, right? So I guess, yeah, so let me read it slowly, and both of us, and then all of us can start. You can tell me what you would do. An aluminum cylinder is 10 centimeters in length, so 10 centimeters in length, and has a radius. So now somewhere along the way, math is coming. You need to know, you're gonna have to use that somehow, but it has a radius of 0.25 centimeters. If the mass of a single atom is whatever, 4.48, blah, 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 calculate the number of total aluminum atoms present in that 10 centimeter length cylinder. And then they give you the density. So what is the goal? The goal is to figure out how many of those atoms are in that little cylinder of aluminum, right? So think of an aluminum rod, and you literally wanted to figure out how many atoms of aluminum are in this cylinder. Okay, how do I do that?
Don't you need to do the volume first of the cylinder?
And why the volume? That's very good. That's very good. Why the volume?
Because even before you get to density, you're going to have to know the volume, because if you don't know the volume, how are you going to find out how many atoms are in there?
Exactly. Very good point. But eventually you still need the volume, because if you look at the density, the thing, they give you the density, right? And the density has a volume unit. It has the CM/3. So if you start thinking about path, well, yeah, you need the volume because you need to know how big it is, but then also you need the volume because somehow, eventually, that number is going to connect to that density. And then we can talk about how we go from there after that. But let's do that first. Does that make sense, Kennedy?
Yeah.
Okay, so I'm gonna, oh wait, I moved to my OneNote, but I'm not sharing. Hold on. All right, so let's go. Okay, so you need to know, excuse me, the volume of a cylinder. Does anybody know what the volume of a cylinder is?
Isn't it pi r squared times the height?
Pi r squared h.
Yeah.
Excellent job, by the way. So we have everything here that we need, which is another reason why this would be a good place to start, because we know pi, 3.14. We know r, because they tell you it's 0.25 centimeters squared. And you know h, or length in this case, which is 10 centimeters. So what is that answer? Let's actually do the answer this time.
Oh.
And I'll do it too, to make sure you guys are doing it right. So, oops. What'd you get?
Got 1.9625.
I did. I got the same too.
What unit?
It would be centimeters cubed.
Good. That's important because you're getting a volume. Okay, so now you go 1.9625 centimeters cubed. Actually, we might have to, there's two sig, well, we'll do that later. All right, so 1.9, this is what we're left with, 1.9625 centimeters cubed. Okay, what the hell do I do with this?
Okay, so.
Would you move down to the density portion and use our volume?
Mm-hmm. Oh my God, why did it stop sharing with you guys? Oh Lord, my computer's going nutsos.
Do we need to use the density given and the volume that we found to find the mass of the cylinder?
Well, yeah, you definitely need to use the density that they gave you. And if you realize, that's actually what I would use right now, right?
Yeah.
Because if I use that, then I can say, I can cancel centimeters cubed, right? Because that thing is 2.7 grams over centimeters cubed. So now it's great because that gets me closer to what I need to be. I need to find out how many atoms there are, but this gets me closer. Grams is closer to atoms than volume is to atoms, right? So now you're in grams. And then what else? I need to find out how many aluminum atoms are there. What's the only thing I haven't used here? It says if the mass of a single aluminum atom is that much, can I use that?
Yes.
Yeah, so this is grams of aluminum, by the way, full units. So in one, there's, wait, hold on, let me see. There you go. That's how I would do it. Tell me what I would write in the next fraction. Exactly.
So would you put the number given on the bottom?
Right, so there's 4.48 times 10 to the negative 23rd grams of aluminum. In how many aluminums?
One atom.
In one atom. That's exactly right, of aluminum. That will then tell you, this cancels, that'll give you how many aluminum atoms. Let's do it. And then let's check the book to see if it's right. So 1.9625 times 2.7 divided by 4.48e to the negative 20, oops, negative 23rd. No, negative 23rd. There we go. Okay, what'd you get?
Well, I'm not understanding, like, underneath the 2.7 grams, is that where our volume should be?
Yeah, that's it. Centimeters cubed. It's 1.
Okay.
I got 1.18 times 10 to the 23rd power of atom.
That's exactly what I got, which makes sense, right? Oh, wait, now let's figure out how many sig figs. I don't know if this is right, but that's what I got too, so we'll check it. But how many sig figs should this thing have?
Should it be 2 sig figs?
It should be 2 sig figs, right? Because of the 0.25.
Mm-hmm.
It's the smallest, and all we did here was multiply and divide. So it would be 1 point what?
1.2.
That's right. 1.2 times 10 to the 23rd atoms of aluminum. Are you good with that, Cameron?
I'm a little.
So you have to go the volume.
I guess I'm just not understanding our first conversion factor.
Sorry.
I know where we got our volume from, but I'm not understanding how we went from volume to
grams.
I mean, in a way, yeah. Like,
yeah, density gives you that. That's what density is good for. Density is actually mostly used because you can relate the mass of something to the volume of something. That is what density does. So the fact that they gave you the density is what is the only reason why we're able to go from volume to mass.
Okay.
Like
I see now.
It's the grams and the centimeters. So you can write it and just put the centimeters underneath it. That's how they cancel out.
Okay, yeah, I had to like see it. I see now. They were already the units.
Let's check the answer. What number is this? Oh, there it is.
You said it was...
Yep, 191. Wait, right? 191? Yep, look, there it is. Okay. Excellent. And this was like one of the hardest ones. It's almost at the end of the chapter. This is easy. So this is what you should be doing. This is what you should be like trying to do, is those type of problems. Because if you notice in my old exams, I don't give you simple conversions. I don't do that. And I say it over and over again in class, but people don't listen. People fail. So I know you work hard, Kennedy. So I'm not saying that about you. But most people don't listen, and they learn only after they fail, which sucks because you should learn before when I tell you. But anyway, I gotta go now, guys, because I gotta eat.
Okay, thank you.
Did this help you?
Yes.
Oh. Awesome.
And for the reach session, like, is this just going to be similar but with like two other people?
Yeah, so
basically
it's different. It's different because they are, you went to some of them, right, Kennedy?
Yes, ma'am.
Okay, so it's a little different this year too. They still don't have tablets, so that sucks. But you start, the first hour is just a main session, and they kind of just ask, you know, they give questions. They kind of go, there's 3 of them. There's the 3 tutors, and they kind of just, you know, go in rotation and ask different questions, easy questions, hard questions, a mixture, blah, blah, blah. But then that's the first hour. The second hour, then you get to decide, because I know before you didn't get to decide, Kenny, they would just stick you in a room. Yeah, that's, I changed that this semester because I told Miss Jones, no, I don't like that, because some people don't want to work on sig fig. Some people want to work on something else. So this, when the second hour starts, then you manually decide which room you want to go in. So depending on what they're teaching, right? Somebody's teaching sig fig, somebody's teaching naming, somebody's teaching blah, blah, blah. Hopefully somebody goes to everybody, you know, that one person is left alone. But anyway, so that's how it's going to be. But yeah, there's going to be more people. Usually my class is not very big. A lot of people don't come to these. They don't. So you know, it's not going to be that many people. But another thing that's different, Kennedy, is that this year we're doing it with another class. We're combining Dr. Nine's class because it was so small last time. I was like, this doesn't make any sense to pay these tutors to only teach my students. Like, it doesn't make any sense.
Wait, so for his class, are they doing the lecture or like
Are
just
they doing what?
classes? Like, it's just his lecture classes that's coming with us?
Yeah, not his lab.
Okay.
But you know, we talked about this because everybody's different, right? And everybody teaches different. And this is the first time that we're doing it with somebody else, professor. So we're gonna see how it works. It can be complete chaos because the way I teach is very different than the way Kirby, Gines, all these other people. So you guys might not be on the same level. You might not, you know, it may be total chaos. And if it is, we'll solve it tomorrow. It'll just be my class and their class. But we're gonna try it.
Okay.
Okay.
Because I remember last semester, and actually Chloe tells me right now, one of the tutors that you're gonna see, Chloe said, like, your class, I mean, I've already tutored people from other professors, and they don't, it's like night and day. You know what she said? She goes, it's like your students go to Publix and everybody else's students go to Piggly Wiggly. And I'm like, I was like, Chloe, she goes, but for real, like, it's just, and it's fine. It's just it's a different way of understanding, right? So literally, like, I can explain your students to like Publix, and then I had to like go to Piggly Wiggly, and I was like, that's hilarious. Mean, but hilarious.
No, it's really true because Naya, remember Naya Rowland?
I do remember Naya.
Like, I was just talking because she has my calculus class.
Let me stop recording. Hold on, but this is